Hey everyone, Jerry here from LlamaIndex, and today excited to host another edition of the LlamaIndex webinar. Today excited to host Ayush from Weights and Biases, and the topic of today's discussion is building LLM applications correctly with LlamaIndex and also Weights and Biases Weave. And so a lot of the focus of today's webinar will be on this idea of LLM as a judge for evaluating your LLM application. And so using, for instance, like a RAG pipeline, we're going to show you how to basically demonstrate, or we're going to show you how to build an evaluation system with LlamaIndex and use Weave for exploring, assessing, and annotating the data to basically better improve your application. So without further ado, passing it to Ayush, who will also just give a general overview of everything. So passing it over to you.
Yeah, thanks, Jerry. That was a nice intro. Like I was in my head thinking how to summarize the first slide itself on what I'm gonna speaking, but that was absolutely right. So yeah, we'll just for housekeeping, I am gonna be presenting some slide deck, and the reason for that is just to show just so that we all can be on the same page. And then I have a notebook that I want to run through to demo building a RAG pipeline with LlamaIndex and things that you get out of the box if you use W&B Weave, and the way you can structure your RAG pipeline and the way you should think about evaluation, and then what alignment actually means when we talk about aligning an LLM judge, right? And if we have some time, we might today internally we had a paper reading group where we discussed this paper called Who Validates the Validators by Shreya et al. And it's a really it's a really OG paper in the space about alignment. And yeah, if we have time, we can maybe discuss the paper a bit as well. Yeah, so the reason I want to first, one sec. Yeah. Yeah, I will first try to ground all of us, get everyone on the same page for this talk, because I feel that, yeah, there are a lot of tech jargons and a lot of terminologies that might mean different thing to different individuals. So it's important that we are grounded there. Yeah, so the first important rule that I really need to ground is that LLM applications are a niche, right? So what you are building, the way you are building it, the amount of dollar you're going to be spending on it, if you have an existing customer that you want to build an application for, or if you are building an application for a targeted new customer base, right? So a lot of factors other than this as well determines how you go about building an application. So your application is not gonna be my application, right? Because of this, it's not a conventional software where we have some of the answers beforehand, or we are defined on the tech stack that we have, right? So the pieces are moving really quickly, and we have to be very adaptive when we're building an application using LLMs. And finally, LLM application building is niche, but every application will have their own iteration cycle. So even though the application itself is niche, but the iteration cycle, even though we think that it can be same for most of us, but still kind of niche in its own way. So I call it weird iteration cycle simply because we just don't know where to start the cycle and where to stop it, right? So one can keep spending weeks over just fixing the system prompt for your application, or one can write some simple system prompt for your application, get some user feedback, improve the system, build some evaluation sets. So the iteration cycles can look very different. That's why it's very weird. And yeah, the bigger final, obviously the evaluation is the differentiating factor. So we need to think through it and do evaluation correctly, right? Despite all this, there are some obvious common denominators, right? So we do have a lot of choices today because the space has exploded. So even though it's application building, LLM application building is not conventional software development, but still relies on a lot of conventional techniques and ideas, which I will discuss later on. Yeah, so on framework side, I believe that there are two big players, right? Like one is LlamaIndex and one is LangChain. I personally love LlamaIndex because I've used it for the longest period of time. And personally, and this is to you, the credit to you, Jerry, and your team, that the documentation is really it's amazing. I would say that I started learning about RAG applications and building RAG, and a underlying concepts because I just went through the documentation. It was good enough itself as a tutorial to learn things when I was starting out. And yeah, and we also need to be very careful about the LLM ops, because if you are a model builder, if you have trained models, if you have built model, you understand this concept of ML ops, right? So the LLM ops itself is a new evolving space, right? And we as weights and biases, we are trying to like lead the way here because like one, we already have like an established trust in the community and among customers, and we are like positioned well to like get a lot of feedback, iterate quickly, and build the best LLM ops application for all of you. Right, and today I will try to showcase. I will showcase W&B Weave, which is our newest offering. And yeah, like honestly, it's just a very lightweight stuff on top of your already existing RAG application. So I will not be talking more about what it is, but rather like showing what you get out of it, right? And yeah, I finally want to comment that personally, I've only seen RAG applications successfully deployed. I'm yet to see like agentic applications. I mean, I might be wrong here, like, but I am still to see like really complex agentic systems in production. Folks are working on it. We ourselves are experimented with it. But yeah, like RAG is there to stay. So I just want to talk a bit about RAG, what it is, so that we all are grounded, right? And again, evaluation is the king. Right. So a naive RAG pipeline is basically data parsing, building a retrieval system, and then querying that retrieval system, right? So even though RAG as a concept seems like a new jargon, but basically it's just grounding your LLM generation using some useful context, right? That's all RAG is. So prompting is how we communicate what we want to be generated using RAG, and retrieval is what gives the RAG application or the LLM the required knowledge or the context on which it should ground the generations to, right? So again, there are a few non-deterministic pieces here, and that's why evaluation is very tricky here. Yeah. So in the demo today, I will show a naive RAG pipeline and how easy it is to build using LlamaIndex. And the application that I will be showing today is basically a very simple version of a RAG application that we had deployed called WANbot. So WANbot is something that me and my colleague Bharat, we have worked on like for over one plus years now. And that was a way for us to learn. And it's basically a Q&A documentation bot on top of our like Q&A bot on top of our documentation. So I will maybe share some experiences while we were building that bot and like thinking about evaluation. Right. So earlier, like we used to build better and state-of-the-art models by relying on traditional machine learning metrics, right? So if you're training a classifier, accuracy is a standard metric where accuracy is based, where accuracy means something, which is the total correct prediction divided by the total number of samples in the evaluation set. So we have a standard definition for accuracy. If you're doing segmentation, IOU is a standard metric. If you're training language models, BLUE, row score or perplexities are very common metrics, right? That we all know of, we have used this, right? But LLM application is hard because one, it is non-deterministic for obvious reasons. And it is very hard to actually define what accuracy means for free-form text, right? If you ask an application like a chatbot to, hey, what is weights and biases, for example, or what is LlamaIndex? Yeah, obviously you can ground it on the documentation, it gives you some answer, but it is generating some free-form text. You do not, I mean, what is the ground truth is something that we all think about, right? So that's one of the reasons it's hard. It's hard to come up with the metrics for evaluating. Yeah, another thing worth knowing is that LLMs are good when it comes to comparing two text, right? So that's why LLM as a judge is a thing, because any powerful LLM, if given, say, two text and asked how close they are or how concise the generated text is to the ground truth text or any other such stuff, it can do a decent job. But again, we know LLM, like when we're building applications, there's something called hallucination. There's something called like not understanding the thing properly. LLMs cannot do reasoning well. LLMs cannot do planning well, right? So there are a lot of things that we need to think about. So, but still, as a first principle, LLMs are good at like comparing stuff, which are hard to do with code. That's why we use it as a judge. And the hardest bit, as I said, is to come up with metrics. And yeah. And finally, I just want to note that LLM as a judge is important, but we need to start and think about heuristical ways of evaluating as well, which means that given you have a ground truth and if you have generation, you can calculate the number of tokens and like check at what margin they are like at what margin the generated text is within, right, the ground truth. Or we can check some other metrics, like if there are code snippets in your ground truth and if there are code snippets in your generated answer, is your generation a valid JSON? There are so many things we can assert by just writing a few lines of code. So we should obviously think about that as well while we are thinking about LLM as a judge. Yeah, again, as I said, everything is like, it's all jargon. If you think about, like, if you talk about it, but deep down, like mostly it's like common sense stuff, right? So if you can use common sense to come up with some heuristics, use common sense to design some LLM judge, we can go a long way. Yeah. Let me just quickly introduce what Weave is. So Weave, and this is more, as I said, I will mostly be showing what you get out of it, and less about what it is and how it's different from other stuff and whatnot, right? It's not a sales pitch. So, but just want to point out that Weave is a lightweight toolkit for one, tracking or tracing your like API calls, your configurations, and more. And it's also a lightweight toolkit for evaluating LLM applications. So the goal here is simply just to build something with the best practices from research and from industry experiences and feedback from customers and whatnot. And like, yeah, and come as a almost zero cognitive overhead, and do not become a lock-in as a tech when you are like, because again, Weave is something which is very generic in nature. It's not opinionated in any way. You can do whatever you want to do. And we're still building it and we're still developing it. And we are happy to take in whatever feedback you have to share here. Yeah. This table here basically summarizes the conventional or traditional model development and the LLM application space today, right? So earlier, the concept of model was the saved weights, right? Today, the model's concept is your pipeline, the composition of the functions, maybe in a class, or the APIs that you're calling. So that's what your model is. Like, it's equivalent to what model used to be in the past. Earlier, the data sets used to be, or in traditional ML, data sets are usually enormous and often labeled, right? But it is not the case for LLM applications. Usually, you build the data set while you are building the application, right? And it's usually human generated and it's usually unlabeled. Earlier, we used, like with traditional ML, we track the experimentation that we are doing. So it can be hyperparameters, it can be metrics. But with LLM applications, and also we're training some really big models, that iteration cycle was not that big, right? Again, machine learning was far more iterative than conventional software development. That's why ML Ops became a thing. But LLM application development is even a bit high frequency iteration stuff, right? And it's inexpensive, so many are trying, but yeah, it's very high frequency iteration. So we need better tooling there, and we need to. And again, there are no metrics. Like, yeah, we talk about evaluation, we talk about accuracy, we talk about faithfulness, correctness, whatnot. But mostly, what we need to track are the activities. What model was used to generate the result, in what time it was generated, how many tokens were spent, how many cents or dollars were spent in that generation, and so many things. And we need to track those things properly, right? So this kind of summarizes here, and Weave is basically built to, again, track the models, track the like version, and track the models and data sets, version, the activities, and so on, and so much more, right? And the best part about this is that we are working really hard to like expand, like build the ecosystem around Weave. We recently launched an integration with LlamaIndex. So if you are using LlamaIndex, and I will show you that only like using one line of code, you start using Weave, right? So if you're a LlamaIndex user, you can start using Weave today itself. And we have Weave integration for OpenAI, for Mistral, for Anthropic. Soon we'll have it. We also have it for DSPY. Soon we'll have it for 3AI and so much more. Yeah. So demo time, but just wanna ground, just wanna share what the problem statement for a demo is today. Yeah. So as I said, we have spent past 1+ years building a WANbot, our question answer bot for documentation. So we today in the demo, I will be using the same data source that we use for WANbot from this website called docs.wanbit.ai, and we'll build a nice RAG pipeline. We evaluate it. We'll then show what alignment of the evaluation means, and in the process we'll show some cool Weave stuff as well. Yeah, I can take a pause for a minute for 30 seconds if there are any questions.
Yeah, I think maybe one of the general question is, I mean, you probably covered this during the demo and future slides as well. When you talk about like all the, for instance, like knobs that you need to think about when you experiment and iterate on a RAG pipeline, like what are some of those knobs, and how do you like compare and contrast that with a traditional ML system?
Yeah, for sure. Yeah, yeah, I think I will cover that bit in the demo. Yeah, let me try.
Okay, sounds good.
Yeah, let me try switching my screen. Yeah, is my screen visible? Yes.
Yeah, you're good.
So this is a notebook that I have running locally. I will share this notebook in a GitHub repository after the talk. But yeah, so the first step is basically me importing few stuff. We are using OpenAI for all the LLM callings, and that's living in this env file. That's why .env. So yeah, we're loading some few things. Ignore 1db stuff here. But the thing that I want to show here is this weave.init. So you pip install Weave, you do import Weave, and then you can just do weave.init. So this is all, this is the only time I'm touching Weave as a code. I mean, at the end, I will be touching a bit more, but this is the only place I'm touching Weave and talking about it more. And then going forward, it's more about evaluation and application building, right? So this is what we are doing, and we'll show later on what it's capturing under the hood, right? So we start building a simple RAG application. If you're already familiar with building an application, it's great. I will just quickly skim through it. But like for those for whom it's new, I'm just trying to run in a way that it makes some sense, right? So the first thing when we start building an RAG application is to ensure a data source, right? So all our data currently is living in this WANDB docs folder. This is basically the dump of our docs.wandb.ai in a markdown format. So we load the data. There are some 380 markdown files, right? Then we basically build this document. Here is a generic container for any data source. Like this is coming from LlamaIndex. So we basically take the text, or rather read the text, and derive some metadata. And metadata are very important when we're building LLM application. And metadata can be both derived, as in like I'm deriving here, like I'm calling raw tokens at the length of the text, right? So this is a derived metadata. The source is something that is inherent to the data itself. So make sure that you keep in mind to have some metadata in while you're building an application, right? These things can come in really handy after, like when you start using advanced stuff like metadata filtering and whatnot, right? So we build this document, and then we do chunking. So chunking is, again, one can feed the entire, because the context length of the LLMs today are quite huge, and you can literally dump in a whole markdown file in your LLM call. But usually that's not a good practice, simply because, I mean, there are folks who are argue against it because there's something called long form context as well. But the point here is that if you have a question, like in this case, in a documentation, like there are H2s and S3s headers, and there are FAQs as well. So for a given question, maybe just a small portion of the documentation is relevant enough. So we don't need to give the whole of the text. Thus, we save on the token cost that we are spending unnecessarily, right? So we're chunking it here, and we are creating these notes, right? These notes are the chunks. So we started with 380 documents or files, and after chunking, we got 1,440 files. Great. Interesting thing, if you're using something called simple directory reader, if I'm calling it right, Jerry, from LlamaIndex,
Yeah.
this is basically just one line of code. I just did this to show that you with LlamaIndex, you have full control over how you wanna build the document, but you can just use the simple directory reader and pass it the path of the directory, and it will create the notes for you automatically. And you can configure that class itself, like the chunk size and everything. So it's really good. Yeah. So
Out of curiosity, have you
yeah.
tried like just playing around with different forms of text splitting, or no? I'm just curious about your experience.
Yeah. I mean, we have tried different chunking strategy. We have even for our WAN-bot, we wrote our own custom chunking strategy, adhering to so that like when we chunk, the code blocks do not go into separate chunks, right? If a code block belongs to a particular header, even though the token limit is finished, when we are chunking, we still want that bit to be part of it. And like there was like, yeah, it's a nice fancy chunking stuff that we have. But yeah, like we have tried a few, but we're not. I personally have not tried the knowledge based, like the graph based stuff as well, like those things, the fancy stuff. But mostly,
Gotcha.
yeah,
No, but that's cool. So you wrote like a custom chunking strategy for one bot. Makes sense.
Yeah. I think, and I also think that, yeah, like for most when they're building application, like the ability to use a framework and customize it as much as they want for their use case is the most important bit, because again, one cannot build generic stuff here in this space. One need to customize stuff, right? So yeah, coming back to the demo, we got the data source and we chunked those data source. Chunks are basically small pieces of text, right? So we need to build a retriever, which is the next step. So for a retrieval, we need to embed each chunk into a vector space. And for that, we are using this OpenAI embedding. We build this vector store index for showing purposes. Here, I'm just like vectorizing the first 200 chunks, but I will show that, yeah, I've already done that in the past and loading the full vector store. So yeah, so we create the index. It basically passes each like batch of chunks to this embedding model and embedding it and creating this vector store. It's very convenient, right? So once you have the vector store, you can create a vector index retriever. So this is the retriever which takes the index, and you can configure the amount of chunks you want to retrieve from this retriever, right? And this is kind of a hyperparameter. Maybe for your application, 5 retrieve chunks is good enough. For someone, 10 is good enough. Like from experience, when we were building WAN-bot, we kind of experimented with this top K value, and 10 turned out to be good. 15 was giving it a slight boost, and at a cost of more token cost. So it was not not a good trade. When we were using just 5, it was really not good on our evaluation set. So 10 is a good number for us. And we need to define an LLM as well. So this LLM is responsible for taking in the user question, the context that has been retrieved from the retriever, and then synthesize a response. So that's why we have a synthesizer, right? Again, all of this can be taken care in 5 lines of code. Like the whole RAG pipeline can be done in 5 lines of code. But I just tried to open it up, like, to show that you have more control over how you're building it. Yep. So, and then, yeah, and you can write custom stuff. If you want to customize the retriever, you can do it. If you want to, like, yeah, build 2 different retrievers, like send the same query to the 2 retrievers. There's this routing concept in LlamaIndex. You can use that. There's so much fancy things you can do with this. And once you have the retriever, the retriever and the synthesizer, you basically pass them to this retriever query engine, and you have the query engine, right? So as I said in the past, a RAG is basically a retriever and an ability to query. with using on that retriever and our ability to synthesize based on the system prompt and the context. So here I'm asking a very simple question. What can we log with weights and biases? Yeah. And note that in this case, the embedding, like the vector store that I created was only using 200, the first 200 nodes, right? So yeah, it gives some answer, good enough. You can log various metrics, visualization, etc., etc. So this is how you basically build a very simple RAG application. And most probably you're going to start here. And one tip as well is that if you're thinking of building, like solving a problem, or if you feel that you can automate something using LLMs, it's a good idea to kind of formalize the problem statement in a way that RAG can come into picture, because we have seen a lot of successful examples of RAG, and it's quite easy to experiment with. It's not very expensive to build a RAG pipeline. So consider building, like formalizing your problem statement as a RAG problem, and then build something and then iterate on it quickly. So yeah, this is how you build it. Great, right? So now at this point in the cycle, what typically you will do is you will go back, maybe change a few things. And the most important thing that you're going to change is the system prompt. You're going to write more instructions to the system prompt. Then again, if like run on few samples and eyeball it, right? Look at how the response has been structured, if it's good enough or not. So this is what you do typically when you are starting out, right? We basically eyeball. This is great. But just a notebook itself is not good enough when you are doing that. And this is where Weave comes in picture. So let me show what we are able to capture with Weave. I'm not sure if my Safari is visible on the screen.
I think I see your Safari.
Is it visible?
Yeah.
Oh, yeah. Awesome. Yeah. So I was talking about Weave. So this is where we go. And like once, so if you remember, all I did was weave.init in the start, and I just did the usual RAG application building with LlamaIndex, right? So this is what got logged. This trace got logged right now, LlamaIndex.query. And if I just show the timestamp, it's 2 minutes back, right? So this is what we did. It took this simple question, what can you log with weights and biases? The generation and the entire thing took some 4,000 tokens. It costed less than $0.01, and it just took 4 seconds to generate this response. Great, but we can do more. We can dig more into it because we have an integration with LlamaIndex. So every event that's happening inside LlamaIndex is going to be tracked with this trace timeline, right? So as a user, you did this. You asked some question and you got some response. Right, and there are it retrieved these nodes. If you remember, the top K was 10, so it retrieved 10 nodes, and I can see what nodes were retrieved, which is great. And then, yeah, and it then synthesized, right? It took in, yeah, it's a query, then the synthesis phase, then there was some templating that happened. Then there was this internally, like it did some retrieval, it did some templating, basically, yeah, putting everything here. Like this is the system prompt. You are an expert QA system that is trusted around the world. So this is the system prompt that LlamaIndex comes off the shelf with. This is what you're gonna be customizing for your own application, right? Yeah, this is the context that was sent to this template. Yeah, so this is it. And then you basically do an OpenAI call where you send in the content, all the stuff, and then you get the response from the LLM, right? And you can maybe want to see in the markdown, you can see this in the markdown format, and they can do more, right? So you have all the information, like it was just you running a RAG application with LlamaIndex, and all the events got tracked, the latency, the time taken, the token count, the cost, etc. Everything was tracked, which is great, right? So this is the first bit with Weave that you get off the shelf. And when you're building application, it's really convenient to go in, check what the response was, because many a times in this case, the response is very tiny, but many a times the responses are going to be big, at least in our case, and visualizing them in a notebook can get cumbersome. So it's really handy. Yeah, so going forward, what I did is used something called weave.model to pack everything together in a single class, simple RAG pipeline. So I'm importing this from this RAG script, RAG.py file. And let me just show you what this looks like, right? It's the same thing that I showed in the past about the vector index and everything. The only good thing here is that we are able to like when we are inheriting from weave.model, which under the hood is a pedantic base model, uh, we, we we assign all these attributes, the chat LLM, the embedding model, the temperature of this application, and so on and so forth. And these, again, these are the same thing. The OpenAI LLM, the embedding model, creating the vector index, building the retriever, building the response synthesis, and then you build the whole query engine. This is the exact same stuff that I showed. The only thing I did was packed in a class inherited from weave.model and mentioned some of the attributes of this class. So this is the application, right? Which with Weave, you can version control and you can track better because again, there are so many moving pieces. And the final bit is when you build the application, you have a call method, right? So when I'm calling this application dot predict with my question, I get the response back. So usual stuff like if you package things in your class, obviously you will have a call method which will return you the response for the given query. It's the same thing. The only fancy stuff here is this decoration of weave.op. So what it does, it allows me to trace this particular method of this function while this whole function whole class has been traced as well. So let me show this in action. So I basically initialize my RAG application again by building the query engine, and that's what it's doing. It's creating the nodes and then building the vector index. And now when I do, what can we log with weights and biases? Hopefully the response is going to be better because this is using the proper vector store built using the full 1400 some nodes, right? So this is what the response we got. Obviously, it seems better than what we got in the past. And now let's go to this URL, this Weave URL that we get. Right. And we got this because there was this weave.init that was called at the very start. So say you build this application and you want to deploy it in production. If you don't do weave.init, you will not be tracing anything, right? And that's good. So you can turn things on and off just by calling initializing weave.init. So yeah, so I packaged everything in this simple RAG pipeline, called it, got this trace link, and now I just want to show what we are getting by packing everything in a class inherited from weave.model. The first thing is you have all the attributes tracked here, right? So the chat LLM, the embedding model, everything is being tracked here. The prediction function, the function that you are calling is also tracked here. So you know that the response or the return of your application is basically a string response and context string in this particular format, which is good. Yeah, and this is the response that you got from the application, and and the rest of this is the LlamaIndex events that happened, which I showed in the past. The only thing is it's all been packaged under this fancy class. What more we can do is we can we can do diff version. So this in the past, a version 2 of this predict method was just returning me the source nodes, which is the list of the nodes from LlamaIndex, which LlamaIndex is returning. But here I decided to basically take the text from those and format it in a way that felt feasible for me, reasonable for me. Yeah, and yeah, we have so many versions of it, which is good. Like you just wrap the whole thing in weave.model and it will out of the box for you, which is good. Let me go
So is the
back.
advantage of wrapping it with a model? I think this is one of the questions that you don't have to like plug in the callback manager anymore, or you just have like more control over what you like log as input and output compared to say just like running the code directly.
Yeah. Yeah. Was there a question? Sorry, if I didn't get you.
Yeah, no worries. So was the advantage of like wrapping it with the weave.model class. Like, so, you package all the code, put it into the rag.py file. Is the advantage of that just like you have a lot more control over like what you log in terms of like the inputs, outputs, the parameters that you define, versus like, without using it?
Yeah, so if there are 1DB users here, and if you have trained a model using and you have used 1DB, so there was something, a concept called config. So when you do 1db.init, you can pass in a configuration file, right? It can be a YAML file, it can be your dictionary, it can be anything, right? You pass in a dictionary and you track those as hyperparameters. When you're building LLM applications, the name of the model, the amount of tokens you want to restrict the generation to, the embedding model, the temperature of the LLM, etc. There are so many moving pieces. You want to track those as well. So Weave.model and packing things with Weave.model allows you to do that. We capture all the attributes of an LLM application with that. If you structure the code in that way, right? And personally, I feel that you're anyway writing all of this thing. The only thing that you're doing is instead of writing the gender init, you are writing the class attributes, because again, it's a pedantic model. Yeah, so this is Weave dot. Yeah, and so now, so this is me initializing the default simple RAG pipeline. So let me just do this, like initialize this with GPT-4o, right? And when we run this again, I changed the LLM, right? Earlier it was GPT-4, so which must be, if we can go back really quickly, it was GPT-4 in the past. Sorry, this is the current one. So the model should have been, yeah, GPT-40613. And now I have switched this to GPT-4o. Got the weave trace. Yeah, and yeah, the response is much better, of like higher quality as well. Earlier, the response was just few lines. Now it's like proper bulleted, and like, yeah, it's showing so much more, which is good, right? It feels a better response. So yeah, this is Weave.model packing, like building. So this is correctly building applications so that you can track everything. The other bit is the evaluation. So when you're doing evaluation, the first thing that you need to think about is the ground truth, or rather the evaluation set itself. It's kind of not a very hard thing today for traditional ML. We have an understanding how to build evaluation set. It's still hard. I mean, it's not that easy, but we have an understanding how to go about building that. But it's very tricky for LLM applications, because one, your application is your application. You are the domain expert, so it's up to you to think about how you want to evaluate it. And there's so many things that's happening in a complicated system that it's kind of get tricky how to evaluate that. But we spent the effort. We did some we spent like few months actually, and we did some manual annotation. We did some back and forth on the eval set, and we came up with 98 samples for evaluating our one bot. So this is what we are using today for this demo as well. There's this subset of the one bot's evaluation set with 20 questions, 20 samples. And I just want to show how it looks like. So in our case, and as I said, this is manually annotated as well. So we kind of spend some time internally to annotate all the answers manually. So yeah, we have some questions, which is good. We have some answer. We have some context. So these are the ground truth context based on which the answers were created. And yeah, and we have some notes by the annotators as well, that this is a clearly generated answer. So these are the things that we capture when we were manually annotating, and we dump all of these in these data sets, Weave.dataset. So the Weave.dataset is another thing that you can use, and it's really useful because again, with this you can version control the datasets as well. I'm not sure if for the eval subset we have two versions, version 0 and version 1. I guess one of them have 20 samples and one of them have 10 samples. So yeah, so you can build a Weave dataset. Again, if you want to learn, if you have questions around how to go about building evaluation set, we kind of wrote a 3-part series on how we did that for OneBot. Maybe that can give some inspiration for your own application. The next bit is the coding. So we for evaluation, we have to start with some sort of evaluation set. Then the next thing we have to think about is the metrics, the scoring for functions, right? So if you have used LlamaIndex evaluation, there's something called correctness evaluator. This is an evaluation technique that uses LLM as a judge. So what it's doing is you basically initialize this correctness evaluator with this LLM, GPT-41106 in this case. This is just one row or one sample. I generate the response with this one sample with my RAG application. And then I pass the generated response to this evaluator dot evaluate, right? So all I'm passing is passing the question, the generated response, as well as the ground truth answer, right? So this is what I got as a generation, and this is what the evaluator, like pass it to the evaluator to get a score like this, right? So it gave a score of 4. It gets some feedback about, yeah, why it came up with that score. But at this point, what I want to say is that I don't know what this 4 means actually, right? The correctness evaluator that I was using was off the shelf from LlamaIndex, which must have a system prompt that's kind of generic in nature and not necessarily catered towards the application that I'm building. So we need to customize that. And from here on, the alignment or the concept of alignment starts, right? So if I can go back to the traces here, because I ran one evaluation and it was just an OpenAI call that happened, right? So this OpenAI call got some system prompt. So this is the default system prompt of correctness evaluator. You're an expert evaluation system for question answering. You are given some information. Your job is to judge relevance. And this is the judging criteria. So your score has to be between 1 and 5. 1 is for worse. 2 and 3 is if you think the answer is relevant but contains some mistake. And 4 and 5, it is fully relevant, right? So this is what we get out of the shelf. And we got some generation from it, right? Some response. It gave a score of 4. Great. Now, what I want to show is how you go about customizing it. So obviously, you will be writing your own system prompt. And the system prompt here is the prompt for your LLM Judge, right? And just a note, you can have, say, 5 LLM judges evaluating different criterias of your application. So you have 5 different system prompts for your 5 judges, and you have to align all of them for your use case. So it's a bit of a iteration cycle where you have to really be determinist. Like you have to be determined to go back and forth and do the hard yards here, right? So this is a simple system prompt that I wrote for this application, that you're a weights and biases support expert. Yeah, this is a way of grounding my evaluator here. And I'm passing it the same thing, and I'm asking it to score between 1 and 3. Good stuff. And then I'm asking it to, this is the user template. You can create this evaluator template. Again, if you go in the code of correctness evaluator, again, like I'm doing kind of exposing things, but I guess you don't need to write so much thing. You can just configure correctness evaluator itself to a good degree. But if you want, you can inherit correctness evaluator that I'm doing here, and you just override the evaluate method of this of correctness evaluator with your own logic. So how you do that is because the reason you can do that is because there's this private there's this LLM stuff that you can call with your input, the query, the response, the references. If you have some more information that you want to pass to your evaluators, to your evaluator or the LLM, you can pass them through KWalks, right? So this is how I customize the evaluator. So the same thing, building the evaluator with a judge and the template, and then again pass the same query, the same response that was generated in the past, and the reference answer that got generated. So the ground truth answer, and the score here is 3 now. And maybe I can say that, okay, fine, the generated answer is relevant and correct. It provides a clear explanation of why initializing WAN-DB before defining route function is beneficial. So it gives the feedback. And since I know what the scoring method is, or like what the scoring criteria is, at least 3 means something to me as an application builder, right? So customization of your LLM Judge is important, right? So that's one bit.
On that note, do you usually find that like the data scientist or engineer defines those metrics or defines those prompts directly, or do they work hand in hand with like stakeholders, like business users, the PM, for instance?
Yeah.
I'm curious in your mind what the interaction pattern is.
Yeah, so it can be either of the one that you said, right? It can be you talking to the stakeholders. Like I was building on an application internally where I was talking to another team continuously to come up with evaluation criterias. The Vanbot was something that we came up for which the evaluation criteria was something that we came at ourselves because we were domain experts in WAN-DB ourselves. So we knew what to evaluate on, right? This paper, who validates the validator, they are employing GPT-4 to come up with the criteria. So they are passing the system prompt and asking a GPT-4 to, hey, this is the system prompt for my application, come up with the criteria that make sense. And then based on those criteria is coming up with either the judge's prompt or some code assertions. So they write some code using GPT-4 based on the criteria and then use those things to evaluate. So yeah, one can come up with the criteria, the evaluation metrics, depending on what they wanna achieve, evaluate based on the conversation with their stakeholders or talking to domain experts or being domain experts themselves. So yeah, the only thing here is that one needs to be very flexible with when they're building the evaluation pipeline. Yeah, so I talked about Weave.model in the past. Just want to talk about Weave.evaluate. This is again a lightweight wrapper to run evaluation in an async mode, which is like so you don't need to write a lot of async stuff for running evaluation, and it's kind of fast. So yeah, so what I'm doing here is this. This is my scoring function, the correctness evaluator. So this is what I was doing in the past. Correctness evaluator.evaluate, got the result, and I am printing the results here. I'm just packing those in a function so that I can return the feedback and the result. It is either a true or a false, and the feedback of the judge. The only fancy thing that I'm doing here is wrapping this again with Weave.ops so that I can trace this using Weave. So this is one of the scoring metric that I have today. I pass the eval dataset, the Weave eval dataset to this Weave.evaluation class, pass the scorer, the answer correctness, and I can have n number of scoring functions, right? It can be both heuristic based and, sorry, am I audible?
Yeah, you're good.
It can be both heuristic based and both LLM Judge stuff. So you run the evaluation, and then you can run the evaluation like this. So what it will take some time, run evaluation on those 20 samples from the eval set and give a score. But instead of waiting, I will just go to the evaluation tab here and show this materials. You can see this is running, but let me show something that I already have. Yeah, evaluation.evaluate, it gives me the evaluation. So I have access to the data set. So I know what data version was used for this evaluation. I know what are the different metrics that were used. Yeah, you can see the few other metrics, but I will show that what it looks like in code. And then I got some score. I can look at the score for say, where is that? Yeah, answer correctness that gave us it gave a score of 70%. Yeah, so let me just go in here. I want to drill down. Like at this point, I evaluated, but as a user, as an annotator, or to understand what happened, why it gave a score of 70%. Again, as I said, it's an evaluation, it's an iteration cycle. I can go in and drill through individual examples as well. I can see this evaluation.evaluate. It basically ran the RAG pipeline and then passed this stuff to answer correctness. And then it gave some score, etc., etc. I can look through let me go here. I can look at the example here. For example, the question was, do you support YOLO v5? And this is the ground truth answer that I have that we annotated manually, right? And then the model came up with this response, right? And I can look through all these responses myself and think, okay, if this makes sense, and if the score, if the model gave it a right judgment or not. So let me find a score where it gave a wrong judgment, or it gave a cross here. So according to the LLM Judge, for this question, I am trying to figure out the best way to organize my 1DB run. I have some answer here, which is a ground truth. And the model generated some answer, which according to my LLM Judge is not correct. And looking at it like this, as a domain expert, looking at it quickly makes sense that it's right. It's not a correct answer, because if you look at the ground truth, it goes in a lot of detail about how you should organize your 1DB run, like about projects, groups. This is the exact thing that should have been answered to a user, but this is not good. So this is a good evaluation. So what I can go in, I can give it a thumbs up maybe, and I can write it as I can write some note about if it's good or not, or I can give it some other emoji if I want to. And then afterwards, I can pull in this feedback in my in code, and then use that as a few shot example for my judge to say that, hey, this is where you did good, or this is where you did wrong. And these are some few shot examples that you can use, because I, as a annotator, annotated that in the UI, and you can like ground your judgment based on those few short examples. And
I like that your annotations are based on emojis.
Yeah, thanks. So I ran, like, this was the new evaluation that I did, and it got some 65% accuracy on this metric. Right, so let's just talk about now alignment. Like, so far, what I've been talking was like how to do it correctly, as well as touch upon alignment as to what it means. The moment I talked about building the evaluation set, or the customizing the LLM Judge. So the moment you think about customizing your system, like you write some system prompt for your LLM Judge, you evaluate, you go in, you get some number from evaluation, but the first thing is that you should be very critical of what this number actually mean. You go in the tooling, in this case Weave, run, like, manually go through different, like, few of the examples, try to understand why it gave the score it gave, provide some feedback in the UI, pull those in. Now you have two options. Option number one is when you are manually looking through like individual evaluation sample and the judgment on those samples, you can come in and modify the system prompt. So you can modify like the annotators LLM Judge's system prompt. That's one way of alignment. Another way of alignment is you use that feedback as few short examples in your system prompt of the annotator, of the evaluator, and that way you can align, right? So this is how we usually do it in practice. There are few research where folks are using GPTs, like LLMs, to build the evaluator and align, like, with some mathematical foundation or mathematical grounding. But in practice, this has worked, and many folks have used this. And personally, we have also used this for Vanbot to align the answer correctness by incorporating, like, proper instructions as to what to look at, what not to look at while coming up with the score, and as well as we provided some few short examples as well. So just at this point, let me just quickly switch to this eval.py file, where I'm just, again, dump the whole thing there, got this evaluator, which is v.evaluation, so that I can import this in my notebook and just do evaluator.evaluate. Again, it's just way of packaging things. So initially, I was using this system prompt for my evaluation, right? The second time, when I am thinking of aligning, as I said, the one way is to improve the instructions. So this is another system prompt that, let me uncomment, let me comment about. Again, we can, like, send these things in a better way, like using argparse and whatnot in separate files. But this is just a demo, so I'm just showing by commenting and commenting. So here, all I did was add these guidelines. So I explicitly mentioned when to give it a 1, when to give a 2, and when to give a 3. So this was me modifying the system prompt based on some of the answers I saw, and improve the quality of the system prompt. I can then go in and evaluate again with this. I did the evaluation actually, and I see I got a 95%. Again, you can ignore the numbers here. That's not the point. The point is that with the feedback, you can go in and tweak the system prompt of the annotator itself. And that's the first step of alignment. And another important thing I want to show here is different heuristic-based scoring methods. So I showed the get answer correctness in the past, but I'm also checking the length of the response that is generated. I'm also checking if there are code blocks in the ground truth as well as the generated answer. I'm also checking if there are bullet points, so like the structure of the answer. I can write n number of other criteria for evaluation based on heuristics, or I can use LLM as a judge as well. So yeah, use a mix of both. That's the trick. So yeah, got some score. The second evaluation that I did was to like modification that I did was to basically provide this few shot example. So where is this few shot example coming from? And that's what I am going to show, and that's going to be the end of the demo. Like one more thing is going to be left. So remember, I gave a thumbs down in the past, like when I was showing, when I went through the response and the generation, and I felt that okay, it's a good response, so I gave it a thumbs up. But I did this annotation in the past. Let me start. Yeah, evaluate human feedback. So here I kind of went through all the 20 samples yesterday, gave some few a thumbs up, few a thumbs down, wrote some notes that this should be added as a few shot example. So yeah, I did this, like retrieve the feedback with the Weave SDK. So that's why I said that, and the end we will show some Weave code. Ran few, yeah, wrote few things to create this few shot example, and then dump these few shot examples in the system prompt of the evaluator, and then ran the evaluation again. Interestingly, it gave a score of 100%. Again, take it with a grain of salt. The WANBot's accuracy on whole of the entirety of the eval set of 98 sample is 82% today, right? So we are still pushing that. So for this toy example, I got 100% accuracy. Great. So this is how you can think about aligning your LLM Judge with your with the iteration cycle that I tried to show with Weave as well. And one final thing that I really want to touch upon is, say if you did two evaluations, for example, right? Let's see, 70, 90, 95. Yeah, let me take these two examples, right? One I got 90% and one I got 70%. Like, let me take this as well, 95%. So what I can do is I can click on this. I selected few evaluations. I clicked on compare evaluations, and this will create a nice dashboard for me with a fancy radar chart. I can see the spread of different metrics here. I can see that like my baseline was 90%. So when it improved to 95%, there's this delta I can see. The most interesting bit is that I can then also look at the question. This is the ground truth answer. Yeah, look at all the responses that were generated. Look through individual traces as to, okay, fine. For this generation, this is a ground truth. This gave a better score. This gave a not a good score. And I can then go in and see why that was the case. So whereas the answer correctness is here, it gave a bad score. I can go in and dig in a bit more and maybe give some feedback here, and then pull in that feedback if I want to pull that feedback in, or I can do like more fancy stuff with like the spread here. Like if I want to see all the evaluations in this range, it will like kind of filter it down to like, yeah, a few examples here. Let me, yeah, just two examples fit this criteria and so on and so forth. So yeah, you can do a bit more like comparative understanding of the different evaluations you have done in the UI if you're using Weave. So yeah, like few, just to do a TLDR, again, like we are over time. I know, I'm so sorry, Jerry. But just to give a TLDR, basically Weave is a great, like a lightweight framework that you can use. LlamaIndex is a great framework to build your LLM application. Build your application as quick as possible, iterate on it. Everything is all about iteration. So you need a good tooling to support in that iteration cycle, and a good framework to be able to be customized for your use cases, and also is in touch with the latest research. So everything that's happening in the space, I think LlamaIndex comes with the implementation really soon, which you can use, which is really great. And yeah, I will share all these code examples and like the relevant reading material and whatnot, what we have created in the past few months, maybe as a tweet or maybe on some other forum. Yeah, so that
This is
was it.
no, this is Yeah, no, this is fantastic. This is a super packed tutorial. I think there's a lot of stuff in here, a lot of great stuff, and I think basically, I'm impressed. You basically just did a live demo of everything, and it basically worked, right? Like you went through all the examples of both like tracing and evals. So I think the only ask I think is from the audience as well is if you're able to if we're able to share some of these materials a little bit more publicly as well, right? In terms of the notebooks, the resources to onboard onto Weave, and then also use LlamaIndex with that. And so we'll try to send those links out in the YouTube recording when this video goes out. But I think I'm sure the audience would be thrilled to have that.